So a classical approach to deal with this relation extraction is a good way is using this article end-to-end relation extraction using deep biaffine attention, and she's an amazing scholar. So we just want to use she draw inspiration from biaffine attention of Christopher Manning, if you remember, for dependency parsing. That I explained his article as well. So the idea is that it proposes a neural network model for joint extraction of named entities and relations between them, without any handcrafted features. And that the key contribution is to extend BiLSTM CRF-based entity recognition with a deep buffer. This is the idea of Professor Christopher Manning in Stanford. So to model second-order interactions between latent features for relation classification. So we see the problem of relation extraction just like the problem of dependency parsing. We draw inspiration from, because after all, we are looking to see the relation between two words in a sentence. So first we do name entity recognition to get good features, and then we give the name entity together with the original token, the concatenated, and now we have multi-layer perceptron for head and dependence, and so we can train it and see what is our relation. For example, relation is origin based in. And so the step one is we concatenate word embeddings and character embeddings to get a representation. And then we do just feed-forward neural network for the input, which is the biaffine of that representation. So this is a good hidden latent feature that we use. After that, we do relation classification, and for that we need two feed-forward neural networks, one of them for head. It's exactly the same, with the same analogy to the article of Professor Christopher Manning in Stanford. So it's not new, everything is like dependency parsing, but we are doing it for relation extraction. And finally, we do joint learning, because not only we use for name entity recognition, but also we augment it with relation classification loss. So our total loss considers both of them jointly. And this is just the idea of Christopher Manning for dependency parsing. So she drew inspiration from his article. And so the data sets that they use is just Ganel 4, and the metric is a fun score as usual. And this is the implementation of DINET. Oh, by the way, DINET is just like PyTorch library. If you see, all of the methods are very similar to that. For example, instead of torch, we use DINET. Because if you remember my article, that one of the articles of Chris Dyer in DeepMind that created this DINET library for dynamic graphs. And so it's more effective because it uses C++. It's more close to the core of the machine, and it's easier to deal with, and it's faster as well.